Hello everyone, welcome to our channel 361 Physics, and here we are representing our first video related with surface tension. And as this is our first video, that's why we have to discuss some fundamental things which can be helpful to solve MCQ question. So let's begin with some important topic here. So here in first topic, it is a shortcut definition of surface tension. Surface tension is just a property of a liquid by virtue of which it occupies minimum surface area. Okay, so any liquid in free condition try to form a kind of droplets or drop, and the nature of drop is spherical because um, sphere occupies the least possible surface area. Okay, so that is about free falling drop. Okay, so in general we can say that surface tension is just a property due to which um, any liquid surface behaves as a stretching membrane or try to occupy minimum possible area. Okay, so this is all about the surface tension. The mathematical expression for surface tension is the ratio of force per unit length, and this is the length of a virtual line drawn on the surface of liquid. And we can say this as the uh, as any object floating on the uh, surface of liquid. Suppose this is any liquid, and uh, this is any kind of object which is on its surface or surface of liquid, then there exert a stretching force. Okay, and this force is known as the surface tension. So in that case we have to take the length of this particular object. Yeah, so in dimension, its dimension is mt minus 2, and its unit is of course Newton per meter. Okay, so its unit can be written as Newton per meter. Okay, so let us move to some more discussion. There are two kind of forces. The force acting between molecule of same substances, and the force acting between the molecule of different substances. So the force which is acting between the same type molecule of same type of substance is known as cohesive force. Cohesive, that means correlated, represent here same. And adhesive force, from this word adhesive, generally represent like a glue. So we can say that the um, as glue uh, attached to different type of substances. So in the same way we can easily recall adhesive force as the force which is acting between the molecule of two different substances. Okay, so cohesive and adhesive force are two type of force. Okay, and its range is of the order of 10 power minus 9 meter, and it is 10 angstrom. Okay, okay, so uh, the reason of adhesive and cohesive force is the intermolecular force. If the intermolecular force of attraction between same type of molecule of a substance is high, then the force acting between the same molecule is cohesive force. And if um, the force of attraction or simply force uh, acting between two different kind of substances is high, then we can say that the adhesive force is more in that case. Okay, so this is all about the adhesive and cohesive force. Some example we can say that if cohesive force is more, suppose this is a glass, okay, and if we glass tube, this is glass tube, and if we insert this glass tube in a water, okay, in a um, uh, any bucket or any beaker containing water, then water will rise over this glass, okay. So the rise of water inside this glass tube is due to the cohesive force act, sorry, not cohesive force, adhesive force acting between these the glass and the water, okay. And there is another example, okay. The example is like, if we are taking mercury, okay, this is mercury in a beaker, and if we insert here uh, same uh, glass tube, then mercury will get here depressed, okay. The height of mercury will decrease in this uh, tube. This is because the cohesive force here in the mercury, the cohesive force is more than adhesive force. That's why mercury cannot move upward in the tube, okay. So this is some example of cohesive and adhesive force, and if cohesive force is more than adhesive force, then the um, liquid does not stick on the glass, and if adhesive force is more, then the liquid can easily stick on the surface of glass and can so rise in the tube, okay. So this is all about the um, cohesive and adhesive force, okay. So now we are moving slightly forward, and this is the expression for surface energy, and it is represented by work done, and its expression is surface tension times change in or increase in area, okay. So surface energy in definition is the work done to increase the surface area of any liquid. That's why it is represented by this W, okay. So surface energy per unit area, this is just uh, modification of this expression. So if we divide the work done or surface energy by unit area, then we will get this expression, and we can conclude that the surface energy per unit area is numerically equal to the surface tension, okay. So this is all about the surface energy and surface energy per unit area, okay. So surface energy for there are two kind of liquid surfaces, spherical drop, this is liquid drop, and soap bubble. So for surface energy for spherical drop, the expression is T times 4 pi r square, but for soap bubble there appears two or twice of change in area. This is because for soap bubble there are two surfaces, one is inside and another is outside, which is in contact with air, okay. That's why in both the surfaces or in both side there acts kind of force, okay. So the work done is uh, work done, sorry, not work done, the surface energy is twice of um, that of spherical drop, because for liquid drop there is uh, only free surface, and which is outside of the liquid, okay. So this is the expression for spherical drop and soap bubble. Now this is expression of work done on breaking a single drop into n number of small droplets having small radius small r, and this is the expression, okay. This is the expression 4 pi capital R square tension times and n raised to the power 1 by 3 minus 1. So this is all about the work done. So now we are moving towards the discussion about angle of contact. So angle of the contact is the angle made by the tangent. Okay, this is tangent to the curved surface of um, liquid. Okay, so um, this is the angle, here is theta, and this theta represents here angle of contact, and this theta is made by this tangent which is drawn on the surface of the liquid. Okay, if liquid stick on the surface of glass, this is glass, then the meniscus of liquid will be concave and the angle of contact will be less than 90 degree. Okay, and if the liquid does not stick on the surface of glass, then the meniscus will be like convex shape and the angle of contact will be more than 90, that means obtuse angle of contact. Okay, and in this case when the concave meniscus appeared, in that case the adhesive force is more than cohesive force, and if the meniscus has the shape of convex, then cohesive force will be greater than adhesive force. There are some important values for a different kind of liquid. Okay, so for pure water and glass in contact, the angle of contact is 0 degree Celsius, sorry, 0 degree, and for ordinary water, that means not in pure form, the angle of contact is lies in between 8 degree to 18 degree. Okay, so for pure water and glass, pure water and clean glass, the angle of contact is 0 degree, and for ordinary water the angle of contact ranges between 8 degree to 18 degree, and for mercury in pure form its value is 135. And from this all discussion we can say that the angle of contact lies in between 0 degree to 180 degree. Okay, so this is all about the angle of contact. Okay, so this is the capillarity, and this is the height of liquid rise in a tube, when it is placed on water. This is the height, and its value depends upon the surface tension, angle of contact, radius of that particular tube, density of liquid, and acceleration due to gravity. So from this we can say that height is directly proportional with the surface tension. If surface tension is high, then height of liquid rise in a tube is more. Okay, so this is about the height, and from here we can say that h is inversely proportional with the radius. That means if we place a tube having fine bore, then height achieved by the liquid will be more. Okay, and vice versa. And also h is inversely proportional with the density, which means if density of liquid is less, then height will be more, and if the density of liquid is more, then height will be less. And acceleration due to gravity h is inversely proportional to g, which means that if acceleration due to gravity is less in any place, then height of the liquid rise in the tube is more, and if acceleration due to gravity is more, then height will be less. Okay, so for example, if we place a liquid, sorry, if we take uh, water, suppose in moon, and if we place a tube having uh, constant radius r or uniform radius, then height of liquid rise uh, in this planet will be more as compared to the earth, because as we know that acceleration due to gravity is less in moon, that's why height of liquid uh, in that tube will be more in moon. Okay, so this is all about the capillarity. Now there is a law which is known as Zerling's law, and it states that the product of height and radius, okay, radius uh, is always constant, which means that uh, if we try to suppose this is a tube and it is filled up to here completely, okay, and suppose if we just uh, cut this part and place the tube in the same uh, liquid, then there the liquid will adjust itself so that uh, the product of height and radius will be same. That means the rise shown in previous case and height uh, of the liquid in second case uh, will be such that the product of h and r will be constant. Okay, so this is all about the Zerling's law. Okay, now we are going to discuss some MCQ. A liquid will weight a surface of solid if angle of contact is. So as we know that if cohesive force is more, then liquid will not weight the surface. Okay, and if adhesive force is more, then only liquid can um, weight the surface of solid. And if adhesive force is more than cohesive force, in that case the angle of contact is less than 90 degree, which means the proper answer is first one. Okay, now we are heading towards question number 2. The surface tension of a liquid with increase of temperature generally. So as we know that if we increase the temperature, then the liquid um, the surface tension of liquid gradually decreases. uh, this is because the stretching behavior of liquid get reduced. Okay, so so we can say the surface tension of liquid decreases as the temperature gradually increases. Okay, so its example uh, is that if we pour, okay, sorry, if we uh, pour, this is suppose this is water, and if we pour some oil on water, then it will like it will seems to be uh, separated, or it seems to be uh, not mixed on with the water. Okay, well, okay, so and if we gradually get that mixture, then oil will uniformly distribute over the uh, uh, water. This is because as the temperature of the water as well as the oil increases, then its surface tension decreases, the surface tension of oil decreases, and that's why the oil can easily spread over the surface of water. Okay, so we can confirm from this example that if the temperature is gradually increases, then surface tension of liquid decreases. ठिक छ, सो यसलाई फेरि एकचोटि एक्सप्लेन गरिदिउँ। यहाँ के भनेको छ भने टेम्परेचर इन्क्रिज गर्दाखेरि सर्फेस टेन्सन के हुन्छ त हामीलाई थाहा छ। टेम्परेचर इन्क्रिज गर्दाखेरि मोलिकुलहरू, जुन वाटर मोलिकुलहरू हुन्छ त्यसमा ऱ्यान्डमनेस डेभलप हुन्छ। ऱ्यान्डमनेस डेभलप हुनु भनेको के हो भन्दाखेरि यसको काइनेटिक इनर्जी, मोलिकुलहरूमा काइनेटिक इनर्जी डेभलप हुँदै जान्छ, इन्क्रिज हुँदै जान्छ। त्यसले गर्दाखेरि यिनीहरूले जुन स्ट्रेचिङ बिहेभियर सो गर्थ्यो, या भनौँ यिनीहरू सकेसम्म मिनिमम पोसिबल एरिया अकुपाई गर्न खोज्थ्यो, अब जुन ऱ्यान्डमनेस डेभलप भयो, ऱ्यान्डमनेस भनौँ यसमा काइनेटिक इनर्जी जुन डेभलप भयो त्यसले गर्दाखेरि अब मोलिकुलहरू फ्री टु ओस्लेट हुने भयो। मतलब पहिलाको जस्तो इन्टरेक्सन एकअर्का बिचमा हुने चान्सेस कम हुनुभयो। इन्टरेक्सन भनेको एकअर्का बिचको जुन इन्टरमोलिकुलर फोर्स थियो त्यो बिस्तारै घट्दै गयो। त्यसले गर्दाखेरि के हुन्छ भने सर्फेस टेन्सन डिक्रिज हुँदै जान्छ। यसको प्रोपर इक्जाम्पल भनेको जति बेला हामीले वाटरमा पानीमा होइन हामीले ओइल ड्रपहरू हाल्छौँ तिनीहरू के हुन्छ भने सेपरेट भएर बस्छ, यसरी डिफ्रेन्ट ड्रप जस्तो सेपरेसनमा बस्छन्। तर ग्रेजुअली हामीले हिट गर्दै जान्छौँ भने के हुन जान्छ भन्दाखेरि यही ओइल युनिफर्मली डिस्ट्रिब्युट हुन जान्छ, युनिफर्मली यो वाटरको सर्फेसमा डिस्ट्रिब्युट हुन जान्छ। त्यो किन डिस्ट्रिब्युसन भयो? किनभने सर्फेस टेन्सन ओइलको घट्दै गयो टेम्परेचर बढे अनुसार। त्यसैले यो यसको एन्सर हुन्छ डिक्रिजेस। So this is question number 3. A waterproofing agent changes the angle of contact. अब waterproofing को अर्थ के हुनुपर्छ भने वाटर रेसिस्टिभ, यानी वाटरसँग इन्टरेक्ट नगर्ने। सो वाटरसँग इन्टरेक्ट नहुनु भनेको कति बेला हुन्छ भन्दाखेरि कोहेसिभ फोर्स, एडेसिभ फोर्स कम, कोहेसिभ फोर्स बढ्ने। क्लियर? सो एडेसिभ फोर्स कम हुनु भनेको कोहेसिभ फोर्स बढ्नु। कोहेसिभ फोर्स बढ्नुको मतलब के हो? कोहेसिभ फोर्स बढ्नुको मतलब 90 डिग्री भन्दा बढी हुनु एंगल। सो 90 डिग्री भन्दा बढी एंगल भनेपछि यहाँ भनेको पनि छ एंगल अफ कन्ट्याक्ट फ्रम obtuse to π/2 फ्रम एक्युट, फ्रम एन obtuse to एक्युट। यो त हुँदैन, एक्युट हुने चान्सेस किन भएन भने एक्युट एंगल हुनासाथ कोहेसिभ फोर्स भन्दा एडेसिभ फोर्स बढ्छ। फ्रम एन एक्युट टु obtuse भ्यालु, सो ग्रेटर देन 90 भनेर चाहिँ हामीलाई थाहा छैन। अब यो obtuse टु 90 त हुने कुरै भयो, 90 भन्दा बढीको कुरा त हामीलाई थाहा छ। यो एक्युट भन्दा बढ्दै गएर obtuse तिर जान्छ। Okay, so this is question number 3. Now we are here in question number 4. A disc of paper of radius r is floating on a surface of water of surface tension T. Then force of surface tension on a disc. अब यहाँ डिस्क र रिङको कुरा आउँछ। म पहिला डिस्कको कुरा गर्छु। डिस्क भनिसकेपछि यो सर्फेस चाहिँ पुरै के छ, अकुपाइड छ अर कभर्ड छ। यसको मिनिङ के हो भने यहाँ लाग्ने फोर्स भनेको यतातिर मात्र लाग्ने, द्याट मिन्स यसको पेरिमिटरमा लाग्ने हो। त्यसैले गर्दाखेरि हामीले के बुझ्छौँ भने यसमा लाग्ने फोर्स हामीलाई थाहा छ सर्फेस टेन्सन इक्वल टु फोर्स पर युनिट लेन्थ, एन्ड यो केसमा लेन्थ भनेको पेरिमिटर अफ दिस पर्टिकुलर डिस्क, द्याट्स वाइ टी इक्वल टु एफ बाई 2πr हुन्छ, एन्ड एफ इक्वल टु टी टाइम्स 2πr। सो प्रोपर एन्सर यो हुन्छ। सपोज यसको ठाउँमा हामीलाई डिस्कको साटो रिङ भनेको भए त्यति बेला हामीले के बुझ्नु पर्थ्यो भने सपोज दिस इज रिङ which means it has two surfaces which are in contact with the liquid. दुईटा सर्फेस छ, एउटा सर्फेस छ इनर सर्फेस यो सर्फेस र अर्को सर्फेस छ आउटर सर्फेस, र दुईटैमा के लाग्छ भने फोर्स लाग्छ। ओके, त्यति बेला हामीले के लिनु पर्थ्यो भने त्यो केसमा हामीले सर्फेस टेन्सन इक्वल टु फोर्स बाई ट्वाइस अफ 2πr युज गर्नु पर्यो, बिकज दुईटा फ्री सर्फेसेसहरू छन्। Okay, I think this is clear. Now we are here in question number 5. Let us discuss it. Due to capillary action, a liquid will rise in a tube if the angle of contact is, of course, angle of contact, if angle of contact is acute, that means less than 90 degree, then only adhesive force will become greater than cohesive force, and then only liquid will rise in a tube. So this is question number 6. The angle of contact varies between, we know that angle of contact actually varies between 0 degree to 180 degree. So this is question number 6. Now we are heading towards question number 7. Let us discuss it. The surface energy of a drop of water of radius r is proportional to, okay, as we know that the surface energy of in generally surface energy is equal to uh, surface tension time change in area, or simply we can write area. And for drop, the water drop is spherical in form, and its area is 4 pi r square. So if we insert here, we can easily say that the surface energy is directly proportional with the square of radius of the drop. That's why option B is correct option. Okay, this is last question of this first video. A metallic wire of density d floating in water, the maximum radius of the wire so that it may not sink. Okay, so suppose wire is placed, this is, suppose this is the liquid and wire is placed over here. Okay, this is the wire. Suppose its length is L, yeah, and its radius is R. And as we know that if uh, the condition says it may not sink, so it means that the tension of liquid, okay, tension of liquid or surface tension of liquid holds its weight or balances its weight. So we can say that uh, surface tension, or simply the force due to surface tension, okay, force due to surface tension of liquid, this is quite uh, correct word. So force due to surface tension of liquid holds the weight of the wire. Now surface tension, we can easily write the surface tension as the product of tension and length. Okay, and what about this weight? Weight can be written as mg. Okay, and then after, mass can be written as the volume, density, and acceleration due to gravity. And again the volume can be written as a times l times d times z. And here we have to write twice l because for a wire there is two length, two free end, one is this and another is from this part. So for wire, suppose this is wire, this is our wire, then the surface which is contact with the liquid is twice of its length. Okay, so that's why we have to write here 2l. And okay, so this is 2l, and we can easily cancel out this. Now I'm going to insert here the radius. Okay, so to insert here radius, uh, we can easily write it as twice l, twice t, and this is area. So its expression, so this is area. Let me write this here because I have to clean this part. Okay, this is now 2t, and this is area of cross section. So area of cross section of wire is pi r square dz. So on rearrangement we can easily write r to be twice of t divided by pi dz square root. So our answer B is correct answer. Well, this is uh, all for this first part. We are making lots of video related to different topic, and we are here introducing another section, and this section is, well, this section is given name as 2000 plus MCQ on mechanics. So we are going to solve more than 2000 questions which is related with first mechanics, and then after remaining topics. Okay, so be ready to get more discussion on mechanics. Okay, so thank you. Thank you for watching, and stay tuned. Please subscribe us, and please write uh, some comments. Which topic would you like to get uh, more discussion on that? So please let us know, and thank you. Stay tuned. Thank you for subscribing. Thank you.